Welcome back. So here we looked at in the last video the Hinge theorem that says if I have two sides that are congruent of two different triangles, I can look at the angle, and the bigger angle will be across from the bigger side. The smaller angle will be across from the smaller side. Let's look at what happens when we look at the converse of that. The converse means instead of knowing anything about the angles, we know something about our sides. So when I look at this one, let's see, do we have any congruent sides? I can see that AC is 24, and that matches with XZ, which is also 24. And then I have 230. CB is 30, and ZY is 30. Okay? And what we did with the regular Hinge theorem is we start with the angles, and we say if this one's bigger, then the side across from it's bigger. If the blue one is bigger, then the side across from it is bigger. But we don't have any information about the angles here. Instead, we do know about the sides across. I know that this 48 is small, so that means it must have come from a smaller angle, because the 50 is bigger than 48, so it must be across from a bigger angle. Okay, so we're just working backwards. It's the converse. Instead of saying if you have a small angle, then you have a small side, we're working backwards. If we have a small side, that means we had a small angle. So now when I want to put my inequality in, comparing C to Z, so C to Z, C is smaller than Z, so C is less than. If we want to compare Z to C, Z to C, Z is bigger than C, so Z is greater than. Okay, let's look at another one just like that. Number 4, I have a single tick mark that matches with a single tick mark. I have a reflexive side that has a double tick mark on it, but it really wouldn't need it, right? Because it's reflexive, so I wouldn't even need that double tick mark. It's going to be the same for both triangles. So then the angles I'm looking at are here and here. And I don't have any information, but when I look across at my two numbers, I do see 28, which is much smaller than the 42, which is much bigger. So I know this purple angle must be bigger than the pink angle. Now, here's the problem with how we have to name them. See how we have to name these? Because they're next to each other, I can't say angle Y is greater than angle Y, right? I can't call both of these angle Y. Whereas over here, since my triangles were completely separate, I could just refer to angle Z and angle C. So I have to see which angle is XYW, right? So XYW is from the top at the pink angle. So I know my pink angle, XYW, is going to be smaller or less than my purple angle, WYZ. Okay, so WYZ is my purple angle, and we know that it is greater than, the purple angle is greater than the pink angle, XYW. Okay? All right, sometimes we're going to have to look at some restrictions that have to be on our figures. Okay? So when I do that, I do have to take a few things into consideration. I have to remember that my side lengths have to be bigger than 0, and my angles have to fall between 0 and 180. Okay? Because I know I can't have an angle inside a triangle that's bigger than 180 degrees. I have to have some degrees left for the other two angles in that triangle. Okay? So we are going to probably have to do multiple equations or inequalities to find our restrictions on x. Once we do that, we're going to look at anything that has an x less than, and we're going to choose our smallest, and an x greater than, and we're going to choose the largest. Okay? So when I look at number 5, and I want to see how big x is, what are the restrictions that I have to place on x, I know that it's this angle here, and I know that the angle has to be bigger than 0, and I know it has to be smaller than 180. So this 5x plus 7 has to be greater than 0. But that 5x plus 7 also has to be less than 1/80. But then we also have our hinge theorem to think about. I see I have a single tick mark and I have a double tick mark. Okay, when I compare that over to the other side of my picture, I have a single tick mark and I have a double tick mark, which means this angle that's across from 12 is going to relate with this angle, so the blue and the orange, which is across from 15. So if I have 15 on one side and 12 on the other side, 15 is bigger than 12. 12 is smaller than 15. So I know this 112 is a bigger angle than this smaller 5x plus 7. So 5x plus 7 must also be less than 112. Okay? So then I'm going to solve these inequalities. So I'm going to start with 5x plus 7 is greater than 0, so I'm going to add 7 to both sides. 5x is greater than 7. Divide both sides by 5. Division property of equality. And x is greater than, when I change that into a decimal, it does make a nice even, not even, but terminating decimal. It doesn't go on and on and on forever. It's not repeating. 1.4. Oops, not negative. Oh, it is negative. I should have subtracted, right? I should have subtracted 7, not added 7. When I subtracted 7, I get a negative 7, and then negative 7 divided by 5 is negative 1.4. Okay? All right, so I know x has to be bigger than negative 1.4 in order that when I plug it into the angle will be bigger than 0 because we can't have a negative angle. Okay? All right, so then I'm going to solve the next one. When I solve the next one, I'm going to do the same exact thing. I'm going to subtract 7, and 5x is going to be less than 180 minus 7 is 173. I'm going to divide by 5. And again, I'm going to go ahead and do the decimal form because it does turn into a nice terminating decimal. It doesn't go on forever. 34.6. So x has to be greater than negative 1.4 and x has to be less than 34.6. All right, one more. I'm going to subtract 7, which is going to leave me with 5x is less than 112 minus 7 is 105. Divide both sides by 5. And x is going to be less than 105 divided by 5 is 21. Okay? All right, so then my next step that I need to do is I'm going to look at my x that say x less than, and I want the smallest value. Okay, so x less than here and here, my smaller value is x has to be less than 21. Okay, then I'm going to look at my x greater than, and I'm going to choose the largest. Well, that's easy because I only have one. X greater than. X has to be greater than negative 1.4. So what this tells me is x has to be bigger than this number, and it has to be smaller than this number. So the way we write that inequality is we write the smallest number first, negative 1.4, has to be smaller than x, right? Because x has to be bigger than that. And then x has to be smaller than 21. So this shows me that x falls between negative 1.4 and 21. Okay, all right, in the next video, we're going to do this next example, which is going to be a little bit similar to the one that we just did. All right, thank you so much for watching.